Okay, so this lesson is lesson 4, and it's on solving compound inequalities. Now, compound inequality is just two inequalities that both have to be true at the same time. And so there are two types of compound inequalities. The first time uses the word and so the example I'm going to give you is that x is greater than 1, and at the same time, x is less than 5. And so to graph this compound inequality, I would make my number line. I would say maybe here's 5, and here's 1, and 0, 2, 3, 4, and 6. And so for the 5, I draw an open circle because it's not equal to 5, but it's got to be less than 5. And same thing here, it's greater than 1, not equal to it. There's not that extra line. And so x is greater than 1. That's to the right of this circle. And at the same time, x is less than 5, and so that's to the left of this circle. And so x could be any number between the two circles. Now, for instance, if x was 3, then we can test it. Is 3 greater than 1? Yes, it is. Is 3 less than 5? Yes, it is. And so you can pick a single number in between those two values, and that could be what x is. Okay? Another way to view this type of compound inequality with the word and is just to write the x in the middle of the two values that it's between. And so this kind of looks like that. X is both at the same time greater than 1 and less than 5. Okay, that's the first type of compound inequality. The second type of compound inequality uses the word or. And so let's use those same numbers. We might say that x is less than 1 or x is greater than 5. And so we're going to draw the same type of number line graph, and there's 1, 2, 3, 4, 5, 6, 0, okay? So again, it's not equal to 1, so we draw the open circle, and it's not equal to 5, so the open circle. Now, x has to be less than 1, and so that's to the left of the 1. Or x is greater than 5, and so that would be to the right of the 5. Okay, so x can't be both less than 1 and greater than 5 at the same time. I mean, if it's 0, then it can't also be 6. It's just one value. And so we could plug in 6 and say, okay, is 6 greater than 5? Yes, it is. And so that's a correct answer. Now, if we plug in 6 here, it's not going to work. But that doesn't matter because it either had to be this or this. And it is this, so that's okay. It didn't have to be both. If it had to be both, we would have said and. Okay, and if we pick a number like 3, for instance, then if we tested it, 3 isn't greater than 5, that didn't work, and 3 isn't less than 1, that didn't work either. So neither of those is true. It's got to be either greater than 5 or less than 1. It can't be both at the same time. Okay, so that's how you graph compound inequalities. Now I'm going to show you how you can solve a compound inequality. Well, if you have the first type, where it was an and, you might have negative 4 is less than 2x plus 8, which is less than or equal to 14. And all I'm going to do is I'm going to solve these basically separately. You could either look at, hey, cover that up, there's an inequality to solve, or hey, I could cover that up, and there's another inequality to solve. You can also do it at the same exact time if you'd like. So for instance, I could say, well, for this inequality, what's happening to x? It's being multiplied by 2, added by 8. I've got to subtract 8 from each side first, PEMDAS backwards, and so that's what I'm going to do. I'm going to subtract 8, subtract 8. Now, if I had covered this up instead, I would have said, hey, what's happening to x? It's being multiplied by 2 and added by 8. First, I've got to subtract 8 from each side, and so that's what I'm going to do. And so if you notice, I'm just doing it all at the same time. Okay, and so what I would get here is a negative 12 is less than, and that makes 0, and so this is just 2x, and less than or equal to 14 minus 8 is 6. And so now again, I'm going to cover this up, and I'm going to say x is being multiplied by 2, and so I need to divide by 2 on each side. So that's what I'm going to do. Now if I had covered this side up, I would have said what's happening to x? It's being multiplied by 2, and so I need to divide by 2 on each side, and so that's what I'm going to do. And so negative 12 divided by 2 is negative 6. That makes 1x. That makes 3. And so that right there would represent the solution for x. X has to be less than or equal to 3, or greater than -6. And of course, we could graph this how we just practiced. Now, for a problem that has the word or, this was an and problem because it was in between the inequality symbols. If we had a problem that said or, like x plus 1 is going to be maybe less than 2, and we said or x, let's see, 2x is greater than 10. We would just simply solve each one of these individually. So I would say for this one, I subtract 1 from each side. I get x is less than 1, or, and then for this one, I divide each side by 2. X is greater than 5. And so that's my solution for an or problem. And of course, I could graph that how we just practiced as well. And that's the end of lesson 4.